whole banana and puts it there.
Here's a classic limit problem. It's indeterminate. If you plug in 0, it's going to give you 0 over 0. So you got to find a different way. With something like this, you should immediately think, let's try to multiply it by the conjugate
I just need to do a lot
of the radical. So you take that right there, and you flip the sign. You leave the two terms the same, and then you multiply it. And so, of course, let me redo that. It's going to be the limit as x goes to 0 of x times that mess. I'll just leave it like that. And then this thing is going to become, remember, a plus b times a minus b equals a squared minus b squared. So it's going to be a squared, which is 1 squared, which is 1, minus b squared, don't forget the parentheses, which is that squared, which is just the square root goes away. So it's that. Which equals the limit as x goes to 0 of x times, again, I'm just going to leave that mess in there. Don't distribute it. It's not even worth it. Over 1 minus 1 minus x. What's 1 minus 1?
0.
So this becomes a positive x. Right? You see why?
Okay.
Because the negative, you have to distribute the negative in?
Yes.
Okay?
I do.
Don't forget that. And then that, in turn, now these things will cancel. Those x's will cancel. That's why I didn't distribute the x in the
And
first
you're
place.
left.
And I'm
I
just
made the
left
mistake of
with...
distributing the x.
Yeah, don't distribute it. It messes you up. So now I'm going to go ahead and write that problem out again. The limit as x goes to 0 of 1 plus 1 minus x. So now I can plug in 0 into here, and I get 1 plus 1, which is 2. I get that.